Good morning, and thanks for joining us for today's webinar. I'm happy to invite Jonathan Carter, who's the project leader for Reverse Engineering and Code Modification Prevention Project. So Jonathan's going to tell us all about his project and how it makes the world safe. So without further ado, go ahead, Jonathan.
Hi, I'm really happy to be here today. Thank you for hosting the webinar and giving me the opportunity to talk about my project a bit further. So first, what we're going to do is we're going to talk about the history behind the project and the context associated with that and how the project came into being. We're then going to talk about current content associated with the project. We're also going to look at the roadmap for what's going to be happening in the future. And I'll show you some of the stuff that I've currently been working on within ArcSam that'll eventually make its way to my project as well offsite. So let's begin. So let's actually look at where the project was coming from. So if we take a step back, I used to be a web app pen tester and did some mobile stuff on the side. Frankly, didn't really know a lot about mobile when I first started off maybe 5 years ago. So in that context, as we all know, in OWASP, most of the vulnerabilities that we like to talk about stem from malicious input provided by the user, such as cross-site scripting or SQL injection, all of the classic stuff that we see in the OWASP top 10. And to mitigate those risks, typically we consider that we have to use some sort of data validation function to move something from being untrustworthy to trustworthy. And these data validation controls have a whole set of secure coding techniques connected to them. So at my days in Fortify as a static code analysis researcher, I used to spend a lot of time focusing on building rules to identify data validation issues where improper coding techniques were being applied. So at the time, when you're in the web space and you're dealing with that problem, generally you don't really have to worry about the issue of reverse engineering or code modification. So you primarily, just don't trust what's coming from out, and you should be good. However, really what's happened in the last 5 years with this dramatic shift towards everything mobile, we have seen that we now have a whole new set of issues to worry about. We have mobile applications. They share this risk. Packaged software, embedded devices as well, where code is sitting on devices which you don't necessarily have physical control. But those things are typically, talking to a back-end server. They're typically interacting with some sort of API or service layer. So we still have the traditional issues that we worry about with web as it relates to data validation issues, because that stuff needs to get processed in the back-end, so you're still going to have those traditional vulnerabilities. But you have additional issues which are unique to environments where the attacker may have physical access to that code. And this is where the integrity problem came into space. So the essential problem we have is that we have software which is typically processing or storing something sensitive on a device which the attacker has physical access to. They can directly access that binary, which is different to the web scenario, and in that case, it gets into a whole other ballgame in terms of what the attacker can do, because they can now modify the code and do whatever they like with it. So you've not only got to worry about submitting stuff to a back end and making sure that it's clean on the back end, but you've got to make sure that the front end can't be destroyed in any way or modified, because typically what that will result in is brand damage, intellectual property loss. It may result in theft as well. So for instance, in the case of DRM solutions, we have to worry about somebody on the front end stealing a license key or cracking the license and downloading content for free when they should be paying for it. The other one, which is big, particularly in mobile apps, is counterfeiting and theft of IP within that actual code itself. So, every few months you're going to see another story about, X number of counterfeit apps hosted on the Google Play site or in the iTunes store that nobody knew about, that resulted in, some dodgy third-party guy selling someone else's app without any sort of, discussion beforehand, and simply ripping off and changing the presentation layer. So those are sort of a small taste of the things that you can see when we're dealing specifically with the problem of preserving code integrity and trying to prevent reverse engineering. So that was sort of my experience coming into working with ArcSand. So I was traditionally a web guy who decided, I was tired of thinking about this particular space. I wanted to do something which was related but different. And so ArcSand specializes just in the problem spaces of reverse engineering and code modification. And so for me, I sort of took that perspective when I was working with OWASP and thinking about all the stuff that I was doing compared to what I'm doing now. So currently, I'm the technical director, and as technical director, I have a pretty cool job. I get to create a lot of technical education content around the space of reverse engineering and code modification. I attend a lot of different conferences, not just in OWASP, but all over the place as they relate to the space of reverse engineering and code modification. I do a lot of proof of concept solutions where I produce applications or I show integrations between various technologies. And saying that, my history as a web pen tester makes it a perfect fit for me to sort of start a new OWASP project. This is something that I always wanted to do. It was always sitting in the back of my mind, and I thought, well, what have I got that's unique? What have I got that's different to what most people in OWASP are doing? And I thought, well, this is kind of a perfect fit because ArcSand is in a related but distant enough space that it's going to create something new and something different, and frankly, something that is an oddball within OWASP. And I thought this is the way that things move forward. This is how it gets creative and interesting from a technical space. So I started my reverse engineering and code modification project back in December 2013. So what are the primary goals of this particular project? What was the vision that I had when I started it? First and foremost, it started off as a coding project, but I decided to make it documentation simply because I didn't have that much time to invest in it at the time. And so that being said, what we decided to do, we being like the royal we, I thought about it and said, well, this is a really interesting technical space that frankly, in my opinion, either gets completely overlooked or people just sort of throw their hands up in the air and say, well, nothing can be done about it, or the risk isn't that great, or they typically just write it off and forget about it. And I thought, okay, well, this is something which could be, this could generate discussion. So let's first and foremost communicate and understand the technical and business risks associated with reverse engineering and code modification, as well as actually look at the real threats from this space. How bad is it? In what scenarios or use cases is it bad? Now, the other area connected to that was the idea of how do we educate and promote an understanding of the actual attack vectors for binary attacks. And by binary attacks, I mean tools that you can use in order to violate the integrity of the application or reverse engineer that application. How can I go about doing that successfully? So I wanted to be able to clearly describe that to various audiences, and we'll go into that later. And lastly, this is the more challenging aspect, is trying to formulate remediation strategies that software engineers can do on their own, independent of any product like Arcsan. You know, it's not the purpose of the project is not to promote Arcsan as a tool, it's to promote awareness of the issues and promotes strategies that engineers can take as a first line of defense in order to make this problem much harder. So we're not going to solve reverse engineering, we're not going to solve code violation or integrity violation, but what we're going to do is we're going to make it as painful and as difficult for the attacker as possible. What are some simple things that engineers can do or that security consultants can recommend that are really going to make a dent in this problem? Now, the secondary goals of the project, I wanted to, when I was looking at this problem, of course, I started off thinking, you know, are there other OWASP projects out there that I can perhaps add to and integrate with that may be impacted by this problem? So immediately the first group that came to mind was the OWASP Mobile Security Group. So in that context, I've been in the background contributing content to all of the OWASP Mobile Top 10s M1 to M10 with an obvious slant towards M10 because of the history. If you don't know, with M10, it's all about the reverse engineering and code modification problem. But aside from that, I wanted to just throw myself into the work and go through all of them and update the content. So the first goal was to integrate with various OWASP projects that are related and also cross-promote where possible. So if it's possible to have two projects promote each other's awareness so that they get adopted by everyone else, that's great. So another example would be with iGoat. So I'm currently on the iGoat team working with Kenneth on coming up with ideas for the next round of pen testing challenges or exercises. Maybe they relate to reverse engineering and code modification, maybe they don't. But it's a related problem space where we can cross-promote and get people aware of both projects. So who could actually use this reverse engineering and code modification project? First and foremost, my immediate thought was, okay, pen testers who are probably in OWASP are probably web people who may not necessarily understand the differences between web and mobile and what's specific to mobile. So immediately I thought, okay, somebody from pen testing should be able to go to this project and get a pretty good understanding of the technical risks as well as potential attack vectors so that they themselves can go off and conduct binary attacks. And then related to that, often pen testers not only need to know what is the issue, but what is the risk associated with that issue. They want to know, how likely is it that someone's actually going to exploit this, or what's the prevalence of this issue. So those are the questions that I wanted to answer for pen testers. Now, I was previously a security architect in one of my former lives as well. So I used to work for Commonwealth Bank in Australia as an enterprise security architect. And I actually ran into a problem at the bank where I was actually struggling with this very problem, where we had a particular device which was hosting code that anyone could modify, and internal to the bank we had baked a solution which didn't actually work. And so at the time I was like, I wish that I had been able to have a discussion and say, okay, this is what a code integrity preservation solution should actually look like. Here are some of the architectural features. Here's how we're going to fix this particular problem from a solution perspective, independent of any technology. What are the things that this solution needs to tick off the box? Also for engineers, I wanted to know, what are some of how do I create various mobile security controls that can take into account integrity? So the classic example which immediately jumped to mind was jailbreak detection. So for instance, in an iOS device, you have to be able to detect that you're running in a jailbroken environment. And the problem is that there are a host of different ways of violating the integrity of the code and bypassing that particular algorithm. So kind of similar to FIPS compliance, where in FIPS compliance, I think it's FIPS, when you're doing the encryption standard, you have to not only encrypt, or decrypt, but you also have to be able to verify the integrity of the algorithm itself. I wanted to be able to answer that same equivalent question for jailbreak detection or other security controls, such as local client-side data validation. We'll show you later a bit more about the controls that need to be taken into account. And lastly, security researchers. So I wanted to be able to reach out to other security researchers who are in possibly connected spaces and have them learn something from this and say, can we cross-promote research? So my own example is, I worked at Fortify as part of the security research group. And so with my static code analysis background, coming into this project, it was an interesting challenge because I was saying to myself, okay, how do I create rules that will identify reverse engineering or code modification flaws if I'm just looking at the source code? What can I actually do with this? So this was an example of cross-promoting between different research disciplines. So let's get more into the sub-projects. So there's two main sub-projects at the moment related to this main project, and we're going to go into some of the details behind the projects, and this will also be a little educational in nature as well. So the first project is the Technical Risks of Reverse Engineering project, and as the name implies, this is all about understanding the actual risks and associated possible attack vectors connected to somebody reverse engineering my code or somebody modifying the code that's sitting on a mobile device or on a firmware device or in cloud. So the sub-project was originally kicked off in January 2014 as a lead to AppSec California. So I was going to AppSec California at the time on behalf of ArcSan. And I presented there and did a whole discussion around all of the different types of risks that I wanted to include in this sub-project. And it was content which was originally created by ArcSan, and what ended up happening was when I joined ArcSan, I joined ArcSan 6 months prior, they said, let's completely overhaul the entire risk tree and how we're describing things and what we're describing and how are we organizing and what's the taxonomy of this. Let's completely overhaul it. So as previous work, I had done that, and then we decided within ArcSan to basically sanitize it, make it technology agnostic, and then release it to the OWASP community. So this particular sub-project was a direct result of efforts at ArcSan, which were then sanitized and released. And we eventually, as a lead up to OWASP Tokyo, I was presenting at OWASP Tokyo approximately 3 months ago, back in March. We had the PDF translated for the Japanese audience as well. So you can go to this particular PDF and find the English and Japanese versions that go through all of the different business and technical risks, as well as recommendations and remediation strategies. And so who should be looking at this project? my immediate thought was, okay, well, pen testers probably have the most immediately practical need for something like this if they're interested in thinking about reverse engineering or binary attacks. They probably need to think about the different avenues of attack and what can they tell their clients if they're worried about this. So that was the first audience. And here's the taxonomy that I had originally come up with when we're talking about reverse engineering and code modification. So in the classic sense of the word, the types of risk that we're dealing with when we deal with reverse engineering is related to code confidentiality. So normally when we think about confidentiality and information security, we're thinking about confidentiality of messages. Here we're thinking about confidentiality of the actual design and implementation of a solution sitting on a mobile device. On the other branch, we have the actual violation of the code itself or the behavior associated with the code. So that's more on the integrity side of things. So we cover off on confidentiality and integrity. I suppose technically you could talk about availability risk as well. So for instance, if you were to, violate the integrity of the code and make it unavailable to somebody, then technically that would be an availability risk. But I think that's kind of stretching the classic definition of availability. But it's technically possible. And so here are some of the, technical risks related to code modification. You'll see that these are fairly platform agnostic and cover both iOS, Android, BlackBerry, Windows phones. Most of the stuff is technology agnostic, and I wanted to do that intentionally so that future work I could branch out into specialty areas if need be. And so at the top, we'll just briefly go through these. We've got the idea of repackaging, where an attacker can essentially take an existing binary, repackage it so that it looks like the original, but it's actually not. It's been modified, but all the signatures pass, and it's perhaps they've modified the presentation layer or the code, but the point is that it passes through undetected as different to the original, but in fact it is different. And also, that would also include counterfeiting as well, where someone can switch out the presentation layer. Related to that is method swizzling, where we can perform code substitution at runtime for a particular app. So if we can perform code substitution at runtime using method swizzling, then we can do a whole host of different things, and we'll talk more about that later. We can also do security control bypassing, where somebody in some way is able to modify the code itself, either directly via binary modification or through things like method swizzling in order to bypass particular parts of the code and get right in. Immediately I think about offline authentication when I think about this. The next one is automated jailbreak and root detection disabling. So in this case, we think about things like XCON, the XCON community who uses automated tools and automated scripts in order to force the application to run in jailbroken or root detected environment or rooted environments, which is never a good thing. But it's typically the step towards something greater or something more threatening to the app itself. We've also got direct HTML, JavaScript, cascading style sheet modification in hybrid apps. And the other one, which is interesting, is cryptographic key replacements, where people are actually replacing keys used for data security or data storage. And the idea there is that you can violate the confidentiality of data that's been encrypted locally by replacing the key within the binary itself for encryption or decryption. And so here are some examples of where my previous research within static code analysis applies. I put on my static code analysis hat and say, okay, how can we actually try to detect that these things can happen? So in this case, I was able to look at things like, okay, can we identify methods that appear to be sensitive, that are passing privacy-related method parameters? If this is true, if you find this pattern, then this is an excellent or a particularly attractive candidate for modification or for method swizzling by an attacker. So you can see here they're logging into a particular site, and we're calling the login user with username. And so if I'm going to swizzle that, I can intercept this particular call, and basically I've got the username and password, which I'm then going to transmit to a third party, and off you're running. I've now got your authentication credentials. Here's another one where we can do things like, is it going to be easy to bypass your jailbreak detection algorithm? So there's a number of different questions that we can look at when we're looking at jailbreak detection. We can say, first and foremost, you can look at the method prototype and say, okay, is this a jailbreak detection algorithm? Is it returning a simple yes, no? And if it's doing something sensitive and it's returning a yes, no, then I, as the attacker, if I can also get that if I can force that method to always return true or always return false regardless, then this is an excellent candidate for modification. So here, we can inject code, or we could even do something as simple as method swizzling in order to bypass the jailbreak detection algorithm. I'm just looking at the example now, and there's other things we could do. So for instance, we could intercept file existed path. And if we see that someone's looking for the cydia.app within file existed path, then just simply say, no, there's nothing there. So there's a number of different, so here you could do method swizzling. You could do binary modification as well, where you simply go in with a hex editor and force it to always return false in this case. So that's just a touch on the code modification side. The reverse engineering risks are pretty standard stuff. This one's a lot harder. And as mentioned in the later list, we were talking about this the other night. It's the reverse engineering risks. When you're trying to mitigate these, basically you have to draw a line and say this is the acceptable level of, this is how much it's going to cost somebody in order to successfully reverse engineer this. And the gold standard is if they have to go towards simulation, in other words, they have to, if they're forced into dynamic analysis, then we've done our job with respect to reverse engineering, because then we're moving from static analysis into dynamic analysis. So reverse engineering is primarily concerned with performing static analysis, in which case we have to worry about what are we exposing. In this case, are we exposing too many method signatures? Associated with that would be data symbols. Are there class fields that are easily available for tweak? What are we exposing in our string tables? That's an interesting one unto itself. So in string tables, we can do a string analysis, and typically there's going to be all sorts of juicy information within those string tables about back-end systems, passwords to infrastructure in the back end. There's all sorts of studies out there that have been done on the string tables themselves. Now, related to that as well is, well, kind of related to that is this notion of application decryption. So if I can bypass code encryption, then I can automatically get access to the original code, and then I can reverse engineer it. So there's a whole host of tools like Clutch, which you can use to bypass the iTunes code encryption and then go back to business as usual and conduct your reverse engineering risks. And of course, related to reverse engineering risk is the risk of actual algorithm decompilation and analysis. That's an interesting one. Oftentimes there's a lot of algorithms where companies are literally living and dying based on their algorithm's effectiveness or the speed of the algorithm. So if one of their adversaries can decompile and analyze and reproduce that algorithm, then the original company who created that IP can literally be out of a job because there's no longer any sort of competitive differentiator. And here are some examples where, once again, we look at it from a static code analysis perspective. We see some constant keys, which are, if you look at the variable, you can say, okay, that looks like a key and it's being assigned something constant. An attacker is going to do a string analysis, string table analysis, and immediately pull out these keys. So this is another interesting one where we can do things like at runtime, if we're trying to prevent someone from actually understanding the control flow, they're going to try and insert a debugger. So we can do things like identify where should you be detecting a debugger within your process that you weren't expecting. So are there source code rules that you can follow and say, okay, this is where I should probably be putting a debugger check? So that's the RISC project as a whole. It's still fairly young in its infancy. It's only been around since January, as I said. We're going to talk more about future roadmap plans for that particular category. The next one, which I think hits more home to me, is the architectural principles sub-project. So the architectural principles sub-project is really speaking directly to security architects. So this one was created in April of 2014. As I said, the intended audience was the security architect, and I was imagining myself, 5 years ago in this scenario where, I was the security guy who was running into a problem with code integrity on a device which was being given to customers. And the problem was that was a scenario where it was an untrustworthy environment hosting code, which, if modified, could directly result in, business risk or unacceptable business risk. So at the time, I was like, well, I wish that I had something like this where I could go through and say, okay, what are the controls that I need? What are the things within these controls that I need to worry about? What are the architectural principles that, so in OWASP we have our standard set of OWASP principles in application security, such as, applying defense in depth, avoiding security through obscurity, those types of things. Can we extend that to the conversation of integrity preservation? So, so this project focuses on controls and principles. And so here are just briefly some of the different types of controls that you as an architect may need to worry about if you're interested in stopping somebody from reverse engineering or modifying code. So earlier I had slightly hinted at it when I talked about anti-debug controls. So anti-debug controls basically ensure that somebody can't actually insert a debugger within your process at a particular time and then go to town and start inspecting control flow. This is a very difficult problem unto itself. There's a whole host of different ways of trying to be clever about getting around debugger detection algorithms. So that's an interesting one. Now, related to integrity is this notion of checksum controls. So with checksum controls, it's basically we can look at and take a fingerprint of a particular region of code or a region of data at build time when we're compiling it, and then compare it against what we see at runtime. And if the two are the same, then you know that somebody has not modified that actual code or data. However, if the two are different, then you know someone's tinkering or playing around with it and you can try and do something about it. But the point of the checksum control is to try and detect that something is going wrong. Static damage is an interesting one. So static damage controls are a whole other host of issues, which what we can do is when we are building and compiling our application, we can actually pre-damage certain regions of the code or data that are sitting on disk. So when you're looking at the final binary, it's actually going to have parts of the sensitive code will be replaced with garbage or whatever else you want, and then the actual secure part or the original correct part will be encrypted and sitting somewhere else within that binary. Obviously heavily obfuscated to the point that it will be very difficult for an attacker to figure out at runtime where this code is located. But the idea is that while it's sitting on disk, it's encrypted so that if I do static analysis, I can't actually identify what the actual code is doing because it's encrypted and the stuff that is there is actual garbage, so you can be wasting people's time that way. Now, dynamic damage control is an interesting one. This is actually directly connected to the Target incident, believe it or not. So in the Target incident involving credit card theft, there was memory scraping going on. Now, what happened was the malware was scraping memory that had unencrypted content in it. Now, with the dynamic damage control, the idea is that code or data is damaged while it's on disk, and when it's brought into memory and repaired back to its original state before execution, you can execute that code, but then afterwards you immediately re-damage that particular code or data while it's sitting in memory. So in the case of the malware, the attacker was able to conduct a binary attack within the memory space. Had they been applying some form of a dynamic damage control, they would have been able to stop the actual memory scraping from happening. Now, connected to, once again, one of the things that you have to think about if you're thinking about reverse engineering is obfuscation. So a lot of people, when they see this project, they automatically just think it's about obfuscation, but obviously by now you should start to see that it goes far beyond obfuscation. Here, we will talk about obfuscation briefly. Obfuscation is basically allows you to apply things like instruction block chopping, symbol renaming, symbol shuffling. There's a whole host of different techniques that you can use, like polymorphic obfuscation, in order to make the reverse engineer's job a living hell. Now, the challenge with obfuscation is that when you apply obfuscation, you can be negatively impacting size or performance at the same time. So this is a control which has limited applicability and isn't necessarily, it's not, you should be avoiding security through obscurity at all times. So you shouldn't just be relying on obfuscation as one of the tools in your bags. Now, related to that is the renaming control, where you can just basically rename stuff directly within the binary itself. And this is considered a lower grade form of obfuscation, where you won't have any of the size or performance impacts that you may have through your classic obfuscation techniques. And connected to that is the string damage control. The string damage control will basically allow you to damage or encrypt the contents of a string table while it's sitting on disk, so that when you do a string analysis against that particular table within the binary, the attacker won't be able to find anything very useful as a result of doing the simple strings against it. And once again, we have controls related to the detection of hostile environments. So when we are running this code in a jailbroken or rooted environment, that's a hostile environment, which gives you a whole host of other security nightmares to think about. So you have to think about applying that control at runtime, and how do you respond to that? It's a whole other set of questions if you detect that things are going wrong. So that's the architectural principles project. It's currently It's still fairly young. You can go online and find all sorts of information. It also explores, it takes you through the actual steps of a binary attack and what an attacker is going to be doing at runtime. And so when you start going through those steps, you can then start formulating, okay, what are the controls that I should put in place in order to make this as difficult as possible. So the Principles project is really good for someone who has very little idea about how to conduct binary attacks. So it's an excellent place to start. I recommend starting there. So roadmap for the future, ideas for things and where things are going to go with this project. So right now, one of the things that I'm really working on is technical videos. So through the technical videos, what I want to do is highlight particular attack vectors for binary attacks. So this is the highlighting. The videos are going to be, you know, very complete and give you a whole exploration of, you know, potential attack vectors. Really, this is going to help the mobile security group as well, because I'm working with, in the second point, there's going to be tighter integration with the mobile security group. I'm working with them to produce videos that illustrate the different types of mobile top 10 issues, M1 all the way through to M10. Obviously, based on my background, I would start off with M10, but I'm totally capable and able to contribute to the others as well. So we're going to go across the board and create various videos and, you know, create them as links to the top 10. So that'll be kind of cool. And today I'll actually show you one of the videos that I'm working on. What we're going to do is I'll show you, I think it's a Buck Smalley modification video just for the fun of it. And that's going to be scrubbed and sanitized. It's within ArcSan at the moment, but we're going to be sanitizing it and then releasing it to the greater community. It's sanitized. It's branded in the sense that we're using a banking proof of concept app which has an ArcSan brand on it because it's the ArcSan POC. But what we're going to do is switch it out for something OWASP branded and then conduct the same attacks. Just for fun, I'll actually show that to you now while we're all together. So let's see. Here we go. So I'll just play the video. Well, let's see. Yeah, let's just play the video.
Let's modify a banking app to redirect money issued from a victim to a hacker's account using an Android app. To do so, a hacker must first download the Android app and convert it into Buck Smalley. Then the attacker will examine the Buck Smalley code to identify a method that issues a money transfer request between two banking customers. Next, the hacker modifies the Buck Smalley code and forces the app to always transfer the money to the same account owned by the hacker. Buck Smalley code does not require a great deal of effort to understand or modify. Here, the victim issues a payment transaction to Bob for rent of $350. If we look at what transaction was processed by the bank, we see that the phone actually issued a request to transfer $350 to the hacker instead of Bob. The victim is none the wiser that the money went to the wrong person. The hacker's modification was indeed a success, and the hacker has now stolen money.
So that's an example of the types of videos that I produce, and so we're going to be doing a version of that and releasing it to OWASP, and we can go through the list and create all sorts of fun and interesting attack vectors that are educational in nature. Really, you know, targeting the pen testers and those types of people who, you know, play with mobile security on a daily basis. I'm also working on the iGoat project, and I'd like to, so in the iGoat project, I'm the lead engineer on that project doing actual iOS implementation of the exercises. So for me, I thought, okay, this is a good opportunity to keep my coding skills relevant and, you know, get my hands dirty and just go for it and create exercises and stuff. So Ken and I are still we keep talking about updating the iGoat and making more exercises. So I'd say the binary modification and reverse engineering stuff could be an interesting and fun add-on to it. I know I did capture the flag in July and or capture the flag at the last DEF CON, and in that they actually had a bunch of binary modification and reverse engineering games within the actual capture the flag. So I figured that maybe we can add it to that. But yeah, there's a whole host of different things, and I'd like to work together more with Jack Menino on DroidGoat and have tighter integration between iGoats and DroidGoat, because both are tools that target developers or pen testers to educate them on the risks. So and so one of the other areas which might be interesting to focus on is creating another sub-project dedicated strictly to just the reverse engineering branch of things. That's always just been an interest of mine on the side as to, what are the actual effective techniques that you can apply for reverse engineering. There's a whole host of different things that have different impacts on the application with respect to size and performance. So it's always been one of those side projects of mine that has always interested me. So I'd like to create a sub-project that focuses on, what can I do within my projects as an engineer in order to enforce or make it very difficult to reverse engineer stuff. I'd like to go into much more detail behind that. So that's it at the moment. If anyone has any questions about the projects or they'd like to get involved, please feel free to email me. This is my email address. I guess that's it.
Jonathan, this is Kate. Thank you for that. That was a great presentation. There were a couple of questions from some attendees, and
okay.
Most of them came from Ashish. So Ashish, if I could unmute you, if that's okay, and then you can ask your questions to Jonathan. So give me 1 second. Okay, Ashish, I've unmuted you if you want to go ahead and ask your question. You have to unmute yourself as well. Okay, well, one of his questions, until you can get the audio, says, where would you want to place something like static damage control? On the smartphone OS concerned or in the App Store?
Okay. So the idea is you can apply, you would apply static damage controls. You would do that within the actual app itself. So I think he's asking, do you place it within the actual operating system, like at the OS level versus the app level? And so you apply all of these controls that I've spoken about to the actual mobile app itself. And you would apply a static damage control to a very limited region of code or data that you're interested in protecting. So the idea is that static damage can in fact have a penalty in terms of performance impact. So you want to be very judicious and careful about where you're applying it and how much of the code or data that you're actually applying it to. Because obviously you have to undamage it when you're about to use it in memory. And so you're going to have to be able to decrypt it or replace it with something which is good. So that's going to have an impact. And then you have to ideally redamage whatever is in memory immediately after use. So those are the big things that you have to worry about. But it's most appropriate to put it within the application itself as a layer of defense in depth. So, for instance, the iTunes code encryption, in theory, provides encryption for you, but the reality is that that's only for stuff which is sitting on disk, not in memory, and we already know that we can bypass that using tools like Clutch. So it's really not something which you should rely upon. So the same goes here. We apply the principle of defense in depth, and apply static damage on top of whatever iTunes code encryption is providing, because an attacker is going to be able to breeze right past that. And we're going to be releasing videos that show actual iTunes code encryption disabling as well using Clutch.
Great, thanks. There were two other questions, and I copied them into the chat window, so hopefully...
Oh, great. Okay. Let's check it out. Okay, so Ashish has asked, what about all those apps which disguise their true intention as malware?
Ashish, I've tried to unmute you again. Are you able to speak now?
Hello?
Hi.
Hi.
Hi, this must be Ashish.
Yeah, it's me. It's Ashish.
Your question about, so you had a question about apps on the iTunes Store disguised as malware?
Yeah, there were a lot of apps coming, right, last year. I don't know what exactly they used, but they were able to, how do you say it, when you go to the initial screening in the iTunes App Store, it shows that it's a clean app, but the moment it enters the App Store, then it, it changes its into some kind of a malware or something.
Yeah, so there's a very disturbing rise in the amount of malware which is coming into the stores. So one of the first big mistakes I think that most of the people on this call will probably appreciate is that the iTunes review process, from a security perspective, is kind of a joke, in my opinion. These people they're not AppSec people, they're not MobileSec people. They're using automated tools in order to try and detect any sort of funny business that's going on. So first and foremost, you can go online and find all sorts of quote-unquote tips and tricks that show you how to get around the review process and do things within your code that you probably shouldn't be doing, such as accessing undocumented or private APIs within the system. So that's the first sort of comment that I have on that, is that it's quite easy to bypass these review processes. In the case of Google Play, there's not really any review process to speak of. So the other thing that I wanted to mention was that we're seeing a dramatic rise in things like Dendroid and SpyEye. Now these are automated tools which you can buy online. I think Dendroid costs $300. You can get it from some Russian guy, and it's probably, I haven't actually done it, but I would imagine it would be through the Tor network. And these types of tools are highly automated approaches to doing code modification. So you can literally give it the final binary and it gives you a nice GUI, and you click on it and it says, okay, I want to spy on this guy and I want to intercept all traffic and I want these credentials to go to this particular server which I'm hosting. That level of sophistication. So we can do all sorts of stuff through method swizzling and all of that. That can all be automated using these types of tools. And we're seeing a dramatic rise in the number of people using these tools to infect applications that are then being distributed, via third-party sites or via the iTunes Store. So really the name of the game, in my opinion, is to prevent yourself from being modified in the first place. So a lot of people say, well, you could apply a malware detection service on your device, and that way if you downloaded anything malicious, you should be fine. And that's fine provided that the malware is caught, but also just the fact that someone has modified it successfully can have, profound business impacts for the cases where, the victim successfully executes the malware, as well as things like, it could lead to brand damage, intellectual property theft, fraud, you name it. So my personal recommendation is you should be able to detect that modification is being attempted and respond in some way to thwart the attacker. So that's where these types of controls come into play. So does that answer your question, Ashish?
Yeah, it does. I just want to know, so what kind of, I don't know, feedback do you want? I mean, from this thing, that app, it should give you some kind of a feedback to the developer directly that someone's trying to modify it? Or
this is an interesting one. This is an interesting problem. Now, I've seen some companies where they do things like they phone home. So,
yeah.
For instance, if I detect that someone has modified my code, I can simply choose to go out and issue a web HTTP post, for instance. And if I can issue a post, then I can go and tell someone, hey, here's an incident, and I'm going to report this incident. The problem with that is that it immediately is a giveaway to the attacker that you've got some sort of integrity preservation system in place. And this gets back to you're violating the security principle of error handling, where you're simply disclosing too much information to the attacker. So I personally don't recommend that you phone home or anything like that. In the case of static damage or a repair control, you can actually replace the code at runtime, which has been damaged, with a known good copy. So if that known good copy is good, then you can replace the damaged or modified code with a known good copy and then execute that instead. And then at the same time, if you can do something really subtle, such as if you can phone home in a very subtle way through some other means that isn't obvious to the attacker, then by all means phone home, but don't make it an overt, obvious act that someone will be able to trace after they're making their modifications. Other things which people have done, they do very subtle performance failures or performance degradation. And the idea is that they're trying to trick someone into, calling technical support or calling someone and reaching out and asking for assistance or something like that. And this is their way of discovering that, in fact, a modification has happened. That's another example. And on the other side, the other thing you've got to worry about is if you do these modifications, and imagine you've successfully attained a crack and suddenly everyone has this performance degradation, then you may get swamped with people asking for support for a cracked version of a tool. That itself will have an impact on your company. So I've seen organizations do that. So there's a whole host of different things you can do in response. You can choose to do nothing. You can choose to make an overt phone home. You can choose to try and repair any changes yourself while you're in the program at runtime. You can choose to do some sort of subtle failure that will result in unpredictable behavior and cause the application to crash in an unpredictable way. That's another classic. There's quite a few different things you can do, and the response is really, there's no universal response. It's an art. It's not a science, because each response will have an impact, and you have to make the judgment call as to whether or not it's worth having that impact. Does that answer your question?
Yeah, it does. It does.
Great.
But then what happens if you have the App Store themselves have some kind of a signature matching scheme, where the App Store is able to compare each and every app which is getting downloaded with the one original copy which lies always with them only. I mean, the developer will have to submit an original first.
Yeah, so if you're downloading from the App Store, then you have to worry about a whole set of different problems. So for instance, if you're downloading from the App Store and you know that the code is good, so in theory the App Store preserves your integrity via code encryption. So as long as you're applying code encryption, then you have some way of guaranteeing the integrity of the code. That doesn't mitigate against a whole class of other types of risks related to reverse engineering or method swizzling, for instance, where you're downloading the application onto a device which is jailbroken or rooted. In those cases, you still have to worry about the integrity of the code because other things on the device may in fact tamper with that legitimate form of the application. So yeah, the use case of downloading from the iTunes store takes care of one particular scenario, which is I can guarantee the integrity of what I've downloaded and installed, but it doesn't take care of the whole host of other issues that are outlined in the technical risks. Does that answer your question?
Yes.
Okay. Did anyone else have any questions? I see that we have a question. Do you feel performance impact by using the static damage control will be very high? The performance impact of using something like the static damage control is entirely dependent upon the range of what you are actually protecting, as well as how are you actually encrypting and decrypting that particular content. So for instance, if I am encrypting, only 200 bytes, that's going to take less time than encrypting 50,000 bytes, for instance. As well, if I'm using, a very simple algorithm such as an XOR encryption scheme in order to decrypt that content, that's going to be a lot faster than using a white box cryptography solution or a white box cryptography algorithm, such as using something like AES or triple DES, for instance. So you've got to look at algorithm and you've got to look at range of protection when you want to worry about performance impact of using something like a static damage control.
Great. Jonathan's contact information is listed on the screen. If you have any additional questions afterwards, if you rewatch the video and something comes to mind, I'm sure Jonathan would not mind if you reached out to him about his project.
Sorry, there was one more question which I'm just reading now. There's another question, I'll just read it out. It says, I recently started experimenting with NTRU crypto algorithm instead of RSA to generate keys. I wonder why. So it says, do you feel that if techies increasingly branch out using some of the not so common cryptographic algorithms, instead this can improve basic security posture at most enterprises? So my opinion is that, okay, so obviously in light of what's going on with the RSA, I can understand why you are wanting to switch out and do other things. The purist AppSec in me says that you should not deviate from, or you should not be doing your own homegrown baked encryption algorithms whenever possible. Even if somebody has a backdoor that's a nation state. I think that in some situations that may be safer. I don't know. That's a controversial thing unto itself. But I will tell you that in the case of in the case of my project, I always recommend applying white box cryptography when you are going to do cryptography on a device that you don't have physical control over, because one of the big challenges that we have is that if you are encrypting or decrypting something and you're also storing the key on that device or getting the key and having to do that sort of sensitive operation on that device, there's a very good opportunity for an attacker to intercept that key in some way and then perform some sort of cryptographic key theft or modification and get direct access to any sensitive data on that device. So in those situations, I always recommend white box cryptography, which uses industry non-standard implementations of encryption algorithms as well as key representations. And the reason that I recommend that for this particular scenario is because we want to be able to keep the attacker from identifying what encryption or decryption algorithm you're using. As well, we want to ensure that they're not able to identify or pick out the key from within memory or within the disk itself. And you attain this by using non-standard implementations of these algorithms as well as representations of the keys. So if you're going to go down that path, I would recommend using a white box cryptography solution, but using something which a vendor has created and not something which you've homegrown yourself. Only because I think that homegrown algorithms, there's people out there that are pure theoreticists and researchers who do all of this stuff. So they're going to do a much better job than you are if you're going to try and homegrow this stuff. So, I think that's the last question that I saw. So I just wanted to touch on that. Sorry. So that's all that I had.
No, that's fine. Again, Jonathan's contact information is posted on the screen, so if you have any questions, feel free to reach out to him, and this will be posted on the OWASP wiki under videos. If you go to, it's on the left-hand navigation pane. This and all of the previous webinars are now posted to the video. And one other project we have, the media project with Jonathan Marcel in Canada. He's put together all of this for us, so I'll definitely thank him for that. Okay, if there's nothing else, then that ends today's webinar. Hope you learned something, and we'll see you next time.
Thank you very much, everyone. Bye-bye.